Okay, let's dive right into this. Welcome to today's Explainer, where we're unpacking some truly fascinating source material centered around a highly capable tool known simply as channel. Now, if you're operating anywhere in the machine learning, data processing, or hardware space, you already know the golden rule. Scaling up your data and scaling up your reach is absolutely everything. So today, we're going to break down exactly how this ecosystem hits both of those targets. We'll be focusing on some very specific, highly powerful technical capabilities and the massive open source community that's driving this whole thing forward. So right off the bat, we're hit with a major technical hurdle. How do you go from just 4 electrodes to extra standard 105 positions? I mean, it almost sounds a bit like magic, right? But when you're dealing with headband hardware and EEG data collection, this is a very real challenge. You've got this highly limited physical input source, literally just 4 distinct data points coming from a headband, and you need a high-resolution output that maps to an extensive standard 105 layout. For context, that's the high-resolution EEG electrode placement standard. That is a massive, massive leap in data complexity. So how on earth does the channel tool actually pull off this heavy lifting? That brings us to Section 1, Headband Upsampling. What's really wild here is just the sheer simplicity of the execution. The source documentation outlines an incredibly concise 2-step procedure. Step 1, you just feed the system your baseline data, those original 4 electrodes. And step 2, you simply request the extra standard _1050 positions. That's it. The upsampling engine within Channel just takes over from there. It programmatically bridges that gap between your low-density physical input and the high-density output you desperately need for robust modeling. It's just a remarkably elegant, streamlined way to scale up your hardware's capabilities entirely through software. Moving right along to Section 2, UI-driven data cleaning. Now, as any practitioner will tell you, generating all that complex, upsampled data is really only half the battle. You also have to make sure the data you're feeding into your models is pristine, organized, and, actually usable. The source brilliantly illustrates the workflow they've built to handle exactly that. Through their user interface, you can meticulously manage your data hygiene. You do this by supplying per-file masks via a specific directory called the mask_dir. And here is where the magic happens. These individual file masks are then automatically unioned directly into the target. So instead of dealing with some messy, totally manual cleaning process across huge data sets, the system just handles these individual masks and aggregates them perfectly for you. It is a game changer for keeping your pipeline transparent and highly efficient. Which leads us to Section 3, the open source ecosystem. Of course, advanced tools like upsampling engines and UI-driven cleaning interfaces don't just magically exist in a vacuum, do they? They absolutely thrive on community. If you're the kind of developer who just wants to jump straight into the architecture, the source material points us to a goldmine of open practitioner resources. You get full, immediate access to the model weight, the entire GitHub repository, and literally all the granular technical details you could possibly need. It's a completely transparent setup, purpose-built for researchers who want to get their hands dirty with the code right away. So, who is actually out there using all of this? Well, check this out. Over 150,000. That is the size of the machine learning subreddit community connected to this ecosystem. Just let that sink in for a second. That's a massive scale of developers, researchers, and ML enthusiasts constantly sharing ideas, troubleshooting code, and pushing the boundaries of what this upsampling technology can actually do. It's a total wow moment when you realize the sheer volume of brainpower is centralized in this one hub. But, a community of that vibrant definitely doesn't stop at Reddit. The source points out that this network is super active across multiple platforms. You can connect with them on Twitter, you can dive into the fast-paced real-time chats over on Telegram, or if you prefer something in your inbox, you can stay updated by subscribing to their dedicated newsletter. It's a really comprehensive, multi-channel approach, ensuring you're fully plugged in no matter how you prefer to network. Let's look at Section 4, Partnering for the Future. With an audience that massive, and that deeply engaged, the potential for collaboration here is just off the charts. The channel network actually offers direct opportunities for creators to leverage this massive user base. If you're building something innovative, the source outlines that you can actually partner with them to promote your own projects. Think about it. You can push your own GitHub repo to their audience, highlight your Hugging Face page, announce a brand new product release, or even drive attendance to a webinar you're hosting. It essentially serves as a massive launchpad for your own ML initiatives. Which leaves us with this final, incredibly provocative question directly from the source material. Are you ready to promote your GitHub repo or product release with them? We've seen how Channel seamlessly upsamples data from just 4 electrodes to 1,005 standard. We've seen how it totally streamlines data cleaning by unioning per-file masks, and we've seen the 150,000-strong community backing the whole thing up. The open source tools and this massive audience are literally sitting right there waiting. The only question now is, how will you use this ecosystem to scale your own projects and make your mark? Thank you so much for joining me on this explainer, and keep building.